Hi, grade 10. Welcome to another math video. This time we're going to talk about multiplying polynomials, something often called repeated distribution. What in the world does that mean? Well, you are already familiar with this process when we're talking about multiplying a binomial times a binomial. So we are going to start there with something you already know. If I ask you to multiply two binomials, remember, binomial means two terms. So if I take something that has two terms, times something else with two terms, like x plus 3 times x plus 7. Two terms times two terms is going to give me four terms. Of course, you know that you're going to distribute the x to that x and to the 7. So we're going to have x squared from the x times the x and a 7x from the x times the 7. And then we take the second term in this first polynomial, the 3, and distribute it to every term in the second polynomial. Positive 3 times x is plus 3x. Positive 3 times positive 7 is plus 21. Understand that this binomial times a binomial, when we multiply, we get something that is equal to it. Make sure you put an equal sign in front of there because they are equal. Now, you've probably learned something called FOIL to help you do that process. F meaning multiply the first two terms and then the outer, the inner, and then the last. FOIL is not a mathematical process. It is an initialism technically because it's the first initials of these words to help us remember and keep track when we multiply. This is where those four terms come from. This is where those four terms come from. Now, can this get more difficult? Of course it can. What if, instead of multiplying two binomials, I give you two trinomials? What if we have a plus b plus 1 times a squared minus b minus 5, for instance? It could be any combination of numbers and letters, and they're making up our terms. But know that because it's a trinomial times a trinomial, meaning 3 terms times 3 terms, we're going to expect to get 9 separate terms when we do our first expansion. Well, let's start with the first term, this a, and let's distribute to every term in the second polynomial. A times a squared is a cubed. A times negative b is negative ab. Yes, I could write ba. In fact, it doesn't matter. They're both right. I prefer to put the a first and write them alphabetically because it makes it far easier to find like terms later. A times negative 5 is negative 5a. And then we move to the second term in that first polynomial and distribute the b to every term in the second polynomial. B times a squared, positive b times positive a squared, plus a squared b. Again, I'm putting the a first because it's alphabetical. The second thing in here, positive b times negative b, is negative b squared. And b times negative 5 minus 5b. The last thing in our first polynomial is this first polynomial, pardon me. We're going to distribute it in the same fashion. 1 times a squared is just plus a squared. 1 times negative b is minus b. And 1 times negative 5 is negative 5. There are 1, 2, 3, 4, 5, 6, 7, 8, 9 terms affected. There's a quick and easy way to check and make sure that you haven't missed anything as you were working. Now, when you're done writing out those 9 terms, check for like terms. There won't always be some. I see I've got just the single a cubed here. I've got an a squared with plus. Notice when I move that term, this plus is a part of the term, so when I move it, the plus is going to be in front of it. I see an a squared b, an ab, and a 5a. Now, as I'm collecting like terms, how am I doing this to help myself so I don't miss anything? I'm going in order of the powers of the a cubed, a squared, just an a, and so on. Now I'll start working with what's left, looking at the b's. I've got a minus b squared, minus 5b, minus a b is minus 6b. Please make sure as you're writing that you can tell the difference between your 6's and your b's, and a minus 5 on the end. Now I've got 8 terms, which is what I expected since I combined only the 2. There's the answer to that. It's not pretty, but it does break it up into terms, which is easier for some mathematical things. We're not going to get into the why at the moment, but know that it is going to make some things easier for us. Okay, so we looked at a 2 times a 2 and a 3 times a 3. Know that they don't have to match. I could have a binomial times a trinomial. Of course, binomial is 2, trinomial is 3, and we'd get 6 terms, for instance. I can make it even messier. What if I ask you to expand x plus 3 minus x plus 2 x minus 11? This front stuff is just sitting here. It's waiting. Order of operations say that if there's something inside a bracket, do we do it first? Can't do anything, can't do anything. Are there any exponents we can deal with? Nope. Is there any division? Nope. However, there is some multiplying. That's where we're going to head next. We need to multiply these two binomials. So this first stuff's just going to sit here. X times x is x squared. Uh-oh, what do I do? What's this minus apply to? This minus applies to everything in here. I am doing the multiplying, and then I'm going to get back to the expression. I need to somehow tie what I get when I multiply together in its own little cage to deal with it later. I'm going to put square brackets around it to do that. You can use regular round ones or parentheses, whatever works for you. X times negative 11 is negative x. Positive 2 times x. And last. Now, inside those brackets I have some like terms. Put them together. And then, once you're done everything that can be done inside the brackets, nothing to do inside brackets, no exponents to do anything with. We don't know a value for x, so we can't do anything there. No division. Now we're done the multiplication. Now we need to look at the adding and subtracting. What are these brackets doing? They're reminding me that I need to subtract everything that is inside of there. I need to subtract, distributing my subtraction to every term. Now, where'd those pluses come from? If I subtract a negative, I get the same thing if I add, and adding is easier. Tidy things up. I'm going to move the minus x squared to the beginning. The minus stays with it. I've got an x and a 9x, so that's 10x. Negative 3 plus 22 plus 19. That's what I get when I expand this. Put equal signs to say that I know every line that I'm working with here is equal. Work down the page. That way I don't lose track of things as I'm going, and all of a sudden, oh crap, I'm working with a different question than I started with. All right, go back to your notes. There are a couple of very involved, crazy examples in those notes as well. Work through those, then hit the textbook and give some of these kinds of questions a try yourself.